will, in the name of God and mercy and compassion, in this video, I want to describe and teach it the best selective and easy way selective fuses for your panel and electrical board. First, I have to glance to the standard important standard of electrical manufacture and electrical standard tutorial. First standard is, I want to tell you, DIN, Deutsche Institut Norm, and VDE. This board, the VDE especially, the VDE is the association of electrical technology. This standard comes from the Germany country, one of the countries which most work in electrical field, electrical surging in field. Today, I want to talk with you and describe selective uses for your panel according to this standard. This is standard close to the IEC, International Electrotechnic Commission. Another standard is NEC, National Electrotechnic Commission, American, United States American, and North America. Also NEMA, NEMA, other standard. NEMA, National Electrical Manufacturer Association. National Electrical Manufacturer Association. We have too many subjects in these standards. First, in these videos, I want to describe for you selective fuses according to standard VDA, standard close to IEC, and standard of Germany and Europe standard. EN is Europe norm or European standard of electrical. Okay, the fuses and for the motors, the fuses for motors have a rates according to VDE standard and IEC standard. The rates of fuses for protective lines, panels, low voltage till 1000 volts, 500 volts, 1000 volts, are as 2 fuse 2 amperes, 4 amperes, 6 amperes, 10 amperes, 16 amperes, 20 amperes, 25 amperes, 32 amperes, 35, 50 amperes, 63, 80, 100 amperes, 125, 160, 200, 224, 300, 350, 355, 400, 425, 500, 630, and 800, 1000 amperes, 120, 1020, 250 amperes. They are rates of fuses according VDA and also IEC. For example, we don't have fuses 180. We have fuses 160. We don't have fuses 210. We have fuses 200. Between 220 24 fuses, we don't have any fuses. Also, according to and the kinds of fuses are screw and blades. The fuse diaset according to VDA, also IEC, the classification diaset fuses. DOL nozzle fuses. These fuses, the first time made it by Germany's, and call it D and DO, and also NH blade fuses for low voltage, high rate call it this. Okay, the fuses, class of fuses, fuse classification of fuses also according to link fuses. We have link fuses G1, the G1 fuses and G2 fuses are screw, and they use it for public and general use. But today the GG fuses be substituted by this. Today we use GG fuse for general use of public fuse, for public fuse, protective line and cable. We use GG instead of G1 and G2. And also the rate of short circuit 100 kilo ampere divided two kind 50 kilo ampere. The fuses which has the 100 kilo amperes, we use it for sensitive place, because these fuses can resistant and are safe across short circuit. And also we have GL and GL and GG2. GG is a new one. GL was the fuses for protective line, substituted today by GG. Okay. In United VDA and IEC standard, we have switching three kinds switchings, and also we should use our electromotors according to the switching. Here I want select and describe, and also introduce you with the switching AC3, which AC3, switching AC3, normal switching for screw cage motors, square cage for motors, which this switching AC3, I want to describe it right now and choose fuse it in this switching, because we have too many switching in other standard. For example, NEC design A, B, C, T, D, divided to A, B, C, D, designed electromotor. In AC3, in the German and European norm, with switching AC3, the squirrel cage used for compressors, pumps, fans, solenoid valves, elevators, mixing, conveyors, AC air conditions, and also in this switching AC3. Also, we have AC4 switching for very sensitive switching. Also for the square cage, for the industrial processing industrial, and machine carry industrial. The difference between the switching AC1, AC3-4, and AC3 are we have to choose different contactors, DILM, for example, 7 DILM, for example, and also auxiliary contacts for different auxiliary contacts for this switching AC3, AC1, AC4. Okay, in here, just I want to describe for you switching AC3 according VDE and IEC. Find out the fuses. Find out an easy method. Find out fuse for your panel and your electromotors. Before that, I want to describe for you the rate of electromotors according IEC and VDE and Europe norm. In next videos, I talk about standard American standard, North American standard, NEC and NEMA. And also talk about how to choose the contactor protective motors and overload devices. But in this time, just I introduce for you the easy way choosing the fuses. Before that, okay, the rates of electromotors, three-phase in according IEC and VDE. The fraction kind 0.6 kilowatt, 0.9 kilowatt, 0.12 kilowatt, 0.8 kilowatt, 0.25 kilowatt, 0.55 kilowatt, and also 0.75 kilowatt. And the round numbers 1.1 kilowatt, 1.5 kilowatt, 2.2 kilowatt, 3 kilowatts, 4, 5.5, 7.5, 11, 16, 8.5, 22. Before this, 50, 22, 30, 37, 45. They are rates of electromotors according International Electrotechnic Commission IEC, and also VDE, and also Europe norm, European standard. 45, 55. $75, 90, 110, 132, 160, 200, 250 kilowatt, 315, and finally 355 kilowatt. I told you, I described the next in the next videos about the American standard NEC. American rates electromotors, and their design is different with VDA and Euro. They rated by horsepower. Okay. How you easy calculate fuses for all these kind of electromotors? First, we have three kinds or four kinds starting and running of electromotors. First, DOL. DOL. Use contactors and our load, our here electromotor. This is first. Direct, without any helping from starter to autotransformer and resistance, and also soft starter and drive. This time, the first DOL, I describe for you how you use, how you choose your fuses in an easy way. Okay. In this way, from 2 kilowatts, the fraction rate electromotors, to 2 kilowatt, you choose fuse 4 ampere, 6 ampere. For example, for 75 kilowatt, you use fuse 4 ampere. Less than this, less than 7.75, you use 2 amperes. More than 0.75 or more than 1.1 kilowatts motors, you use 6 ampere. Then from in starting direct on line directly, just uses the one contactors. We use this kind of running and starting in many places, which place we don't have we don't have enough space. We should use of this. And also we want to use most torque in the first initial start. Okay. Then from 2 kilowatt to 75 kilowatt, you use numbers or factors, coefficient, point 0.049. It's important numbers. For example, you have electromotors. You have electromotors 22 kilowatts. In the nameplate of these electromotors, you have 41 amperes. These are nominal amperes for these electromotors. Okay, what is its rate of fuse? Okay, 41 divided 0.49. Come 48, 43, we don't have fuse 43. We have fuse rate 50 amperes. That you're choosing for your electromotors. Very easy. Just divide the nominal current to 0.49. That came out from my experience work in industrial. That's my methods. All this I say to you is my methods. Okay. Other example, tier 55. 55 kilo. You have 55 kilowatt electromotors with 99 current, nominal current of this. Okay, you want to choose the best fuse for this electromotor. Okay, you divide 99 to 0.49. It will be 202. We don't have 202 fuses. We choose close of that 200 ampere fuses. It's very easy and fast. You can find it just by 0.49 from 2 kilowatts till 55 kilowatt. But more than this. 55 kilowatt to 55 kilowatt to 250 kilowatt. Your factor coefficient will be changed to 0.69. Nominal current in nameplate electromotor divided to 0.69. You find if you select fuse rate. Example, (160 kilowatt). You have a 160 kilowatt electromotors, three phase. You want very fast, selective your fuse for this electromotor to running DOL. Okay, 160. Its current 259, the nominal current, rate current of the in nameplate of this electromotor. Okay, divided 279 to 0.69. These numbers I invented. Behruz Ahmadi, suggested to you. Then you find 404. We don't have 404 fuse. Choose 400 ampere fuse. Very fast. You had 160 kilowatts. That's what's rate current of in nameplate. Divided to 0.69, you find your fuses. Very fast. Other example, 250 kilowatts. 250 kilowatts. 250 kilowatts divided 0.69, you find sorry 250 kilowatt rate of fuse, 630 fuse, the current, nominal current in the nameplate of these electromotors, 633 divided 69. Okay, your fuse is 630 ampere. That's your fuse for these electromotors. Rate of fuse. Very easy and fast. Okay, the next method of running. Next method, start delta. Start delta. Start delta for general factors, not sensitive, not very important factor. Okay, for this, okay, we have fuses, contactors, main, contactors, delta, contactors, stop. In future, I talk about the choosing and selective easy way the contactors. In this time, here, just talk about fuse, selective, easy and fast way fuse, electromotors. Let's start delta. Okay, we want to find out and selective this fuse very easy and very fast. From 5.5 kilowatts. Under this rate, we don't use the start delta. We use DOL under this rate. Okay, from this 5.5 kilowatt, UT2 65 kilowatts. Your numbers, constants number 0.79. Example. Okay, example. you have 3 kilowatts, 30 kilowatt motors, 30 kilowatts motors. I have 22 sorted. Okay, 22 kilowatt. You want to find out fast and easy way your fuses. 22 kilowatts. Its rates current, the nominal current in nameplate of this electrodes is 41. 41 divided to 0.79. It will be 50. Exactly 50 ampere. This is your selective fuses. Very easy. That was your electromotor, 22 kilowatt. That was the nameplate current. Nameplate current divided 0.79. Okay, T to 65. More than 65. Other example, 15 kilowatt, current nameplate 29.3 divided to 0.79. Your fuse 37. If you don't have 37, you use 32 fuse. Very easy. Just divide it to 0.79. Okay? More than 65. More than 65. The more than 65 in star delta type 1. Type 1 for general using, not sensitive using. For example, industrial, nuclear, and medical, industrial, and many space, aerospace, or missiles, rocket, many sensitive. We use the star delta type 2, which I described after this. Okay, we have it from 65 kilowatt to 355 kilowatts. We use number 0.98. 0.98. Example. Example. Okay. 250 kilowatt. 250 kilowatt. Kilowatt, and its rate current is 437. 437 divided 0.98, almost 400. The 400 is your selective fuses for 250 kilowatt with nameplate current 437, close to 400. That's your selective current. Okay, that was the for starting type, start delta type 1 for general using panels, and also switchboards, and many of these you have two constant numbers, 0.039 less 2 tier 65 kilowatt and more than 60 kilowatt, 65 kilowatt, tier 350 kilowatts. We divide their nameplate current to 0.98. The result will be your selective rate fuses. For type 3, type 2, the type 2 star delta. The type 2 star delta for the sensitive factories, and I find out two constant numbers which when you divided the current of nameplate of your electromotor to these numbers, you find out easy and fast your fuses, as I described before, for two other running starting DOL and type 1 star delta. Okay, for star delta type 2, from 5 kilowatt to 110 kilowatts, we divide current nameplate plate to 0.80. The result will be your rate of use. Example: (22 kilowatt). The rate, the current nameplate is 41. Divide 0.80. The result is 50. Your fuse will be, your fuse choose is 50. 50, that's your fuse. 50, I think the rate fuse we have 50 or 52, doesn't matter. The standard rate fuse, you choose it, 50. It's very easy. And other example, and more than this, that was until 110 kilowatt. The constant number was 0.80. Current nameplate from 55 kilowatt to 110 kilowatt in type 2 for sensitive industrials. Current nameplate divided 0.8, you'll find out the numbers which is or exactly the fuse rate or close to fuse rate. More than 120 kilowatt to 250, you should 110 kilowatt to 250, you divided current of name plate to 0.95. The result is your rate of fuses. Example 110 kilowatt. Current in nameplate is 196 divided 0.95. Your result is 209. Your fuse is 200. 200 fuse for 110 kilowatts. Electromotors in a star delta type 2 sensitive industrial. The general star delta I told you before, the number was different from this. Okay, this is your fuse over here, 200. Another example, 132 kilowatts. The nameplate current 231 divided to 0.95. You find out 243. Your fuse, the standard rate fuse 250. Very easy and very fast. You just buy the constant numbers which I invented. I find out in many years in industrial. I told you this method for find out and calculate your fuse rate according to a standard VDA, which is very close to IEC and also is a standard Europe norm, and also in Iran and west of Asia. Okay, I thank you. I am Behruz Ahmadi, Iranian electrical engineering, Master of Science, which have too many books published in Iran. I wish you use this video. In next video, I describe how you find out your contactors or relays, and if you want, use protective motors, devices, and soft starter and driver. I told you this is very easy for soft starter and drives and protective for soft drivers and soft starter and drivers. Just your point. If you find your current for finding fuses for drive and soft starter, you divide your rate current of nameplate of electromotor to 98, or you directly you use the fuses close to the rate current of nameplate. Understand? If you, for example, is your current nameplate of your electromotor is 100 in soft starter. When you use soft starter starting, you use also 100 amperes fuse too. In that, I thank you, and just I want to tell you, you directly use the fuses in soft starter and drive according be equal to the rate current of nameplate or close of that, or if you want to have a protective one step more than, for example, is 90 ampere rate current in your nameplate of electromotor, you use fuse 100 ampere. If it's 90 ampere, you use 100 amperes rate fuse. If it's 70, you use 80. One step more. That's very easy for drive and soft starter. I thank you for watching. Stay with me. Please wear a mask for against of disease COVID-19. Thank you very much.